So this is question 5 from the 2010 exam. We need to apply the simplex algorithm and determine the final tableau. Now, applying the simplex algorithm is very similar to when we were using the Gaussian algorithm in earlier years. So when we have a basic variable, as here, that we consider S1 to be the basic variable, it's like saying that this has a coefficient 1 and the rest on that column are zeros. So the point is to turn x1 and x2 usually into basic variables. So we want one of them to have a coefficient 1 and the rest to be 0. Now, we start the simplex algorithm by finding the entry that we will pivot on. So we need to look at the biggest negative entry in the Z row. This is -3 for us. And then we need to look at the smallest positive ratio of the resource values over the coefficient of that column. So these are the resource values. And these are the coefficients that we're going to consider. So we'll have 5/1, and this will be 6/4, which is just 3/2. So the smallest of these ratios will indicate the entry that we would pivot on. So since 6/4 is a smaller positive ratio, then 4 is our entry. And we can now start applying the simplex algorithm. So since 4 is our entry to pivot on, that means that x1 will be the entering basic variable and it will replace s2, which will be the departing basic variable. That means that we have s1 here as one of the basic variables and x1 as the other one. And here we always have Z. Now, in order to turn that 4 entry into 1, we need to divide by 4. When we divide something, then we do the same thing to the rest of the entries in that row. So we need to divide every entry in the S2 row with 4. And that will give us 1 -3/4, 0, 1/4, and 6/4, which is just 3/2. Now, in order to turn 1 here and -3 into 0, we need to again work very similar to the Gaussian algorithm. And so we are going to do this row minus the x1 row. So we will have s1 minus x1 in order for that to be 0. So I'm going to write the calculations on the side. The name of each row will be the basic variables of that row that I'm going to use. Be careful because there's 2 s1s. Every time when I talk about this row, I mean the previous s1. So this will give us 1 minus 1 is 0, 2 minus -3/4 will give us 11/4, 1 minus 0 is just 1, 0 minus 1/4 is -1/4, and then 5 minus 3/2 will be 7/2. You can do the calculations on the side if you want. Sometimes it's easy to get confused, so be careful. And now with Z, in order to make -3 into 0, we need to have Z plus 3 times x1, since we have the coefficient 1, and that will turn this coefficient into a 0. Always keep this in mind. So -3 plus 3 times that will be just 0. Then we have 2 plus 3 times minus 3 on 4, which will give us minus 1 on 4. Then we have 0 plus 3 times, 0, this is 0, plus 3 times x1, which is still 0, so it will be 0. Then we have 0 plus 3 times 1 on 4, so 3 on 4. And then we have 0 plus 3 times 3 over 2, which is just 9 on 2. And now we've done one step of the simplex algorithm, and we need to do the same procedure one more time. So again, we need to find the entry that we will pivot on. We can see that we have only one negative entry in the Z row, which is very helpful. We can see straight away the entry. And since this is also negative, we know that we don't even have to look at the ratio, since we want the smallest positive ratio. So that means that this will be the entry that we will pivot on. And now, to turn that into 1, we need to multiply the whole row by 4 on 11. So here we will have x2, since this will be our entering basic variable now. This will stay x1 and z. So multiplying by 4 on 11 will give us 0, 1, 4 over 11, minus 1 over 11, and this will be 14 over 11. Now, in order to make minus 3 over 4 into 0, so we can have the basic variable form here, we need to take x1 and add to it 3 on 4 times x2. So this will give us, we have 1 plus something times 0, so it will be just 1. This is minus 3 on 4 plus 3 on 4, which is 0, of course. We have 0 plus 3 on 4 times 4 on 11, which will be 1 over 11. And doing this will give us, that's 3 on 11, that's 2 over 11, and 27 on 11. And now for z, we'll take z. Since it's minus 1 on 4, we'll just add 1 on 4 times x2, which will have 1, so, it'll give you 0. So we'll have 0, 0, 1 on 11, 8 on 11, and finally 53 on 11. We can see now that we do not have any other negative entries in the Z row, which means that our simplex algorithm stops here. We do not have any other entries to pivot on, and we can find the optimal solution. Since we do not have to write down the solution for this problem, this is everything for the simplex algorithm method, and that is all.